Okay, couple of just quick review concepts to talk about. Okay, so number one, okay, square rooting and squaring are inverse operations, which means they just cancel each other out. Okay, so what does that mean in terms of what we're going to do? If I had the square root of 5 squared, what would that equal? Just 5. Because the square root and the square cancel out. Now, let's say you don't believe me. Fine. Okay, let's actually square it. 5 squared is 25. What's the square root of 25? 5. So now, is it easier to square it and then square root it, or is it easier to just cancel the square root out? Probably easier just cancel, done, right? Okay? All right. Number 2 information that we need to know, okay? Anytime I have 2 things inside of a parentheses and I square, I have to square both of the things in the parentheses to get a squared and b squared. Okay, so those are the 2 review concepts that we need to know as we move into the first part. Okay? All right. So, number 1. This simply means, okay, based on what we just talked about, I am going to square the 2 and I am going to square the radical. And then all I'm going to do is do each piece separately and then multiply. So, what's 2 squared? What's the square root of 3 squared? 3. What's 4 times 3? 12. I thought I heard 2. Okay, 12. All right. Does that make sense? Okay. So on the second one, okay, I square the 5, so I write 5 squared. I square the square root of 6. 5 squared is going to become 25. The square root of 6 squared, the square and the square root cancel, becomes just plain old 6. 25 times 6 is 150, and I'm done. Okay? All right, try number 3 on your own. And then number 4, since it has a variable in it, we'll do it together. All right, so we should be getting 3 squared, square root of 7 squared, 9 times 7, 63. Any problems with number 3? All right, who wants to say what they got for number 4? Who thinks they got it? Any brave souls out there?
I tried it.
All right. What do you, we'll see. What'd you get?
80A.
80A? Very, very, very close. 80A squared. Okay? All right, so she squared the 4. She squared the square root of 5A squared. The square root and the square cancel, leaving 5A squared. 4 squared is 16, so really all it comes down to is just multiplying 16 times 5. So I think you took the square root of the a squared and made it a. Okay, but realize if you did that, you're going to turn around and square it again. Okay, so very good. 80a squared. Any problems there? Okay, second part. Okay, this is no big deal, only because we've already talked about multiplying with radicals. We've talked about adding and subtracting with radicals. So now all we're doing is just adding a step, using the distributive property. Okay, big ideas from yesterday. Remember, outside numbers multiply, inside numbers multiply. So if I go to distribute here, I am going to get a 10 root 3, because 5 times 2 is 10. They're both on the outside. Then I distribute to the second one, and I'm going to get a minus 2 root 6, since the 2 and 3 are both on the inside.
Isn't that
8 square root 3. How are you getting 8?
Was I wrong?
It should be 2 root 6.
Wait, hold on.
Okay. So if I start with just the first part,
Yeah.
okay, 2's on the outside, 5's on the outside. Neither one of them are inside of a radical, so that's why they become a 10, right? The root 3 has nothing to combine with, so it stays a root 3.
Yeah.
Now, when I distribute this way, it's 2 times 1, which is 2. 2 has nothing to multiply with on the outside. And then root 3 times root 2 is root 6. You said 8. How'd you get 8?
Never mind.
Oh, okay. Now, the question is, can I actually subtract them and simplify some more? And the answer is no. Okay? So sometimes it's just that simple. All right? On this one, if I distribute, outside numbers multiply. So 5 times 2 is 10. Inside numbers multiply. 6 times 3 is 18. Go ahead.
Is it the whole thing, like 5 root 6, is the whole
Yeah.
thing? to
The 5 root 6 is the whole thing. So this entire thing is multiplying by this entire thing. What's separating it is the minus sign. So now this entire thing, the 5 root 6 is going to multiply by the 4. And since 5 and 4 are both on the outside, I'm going to get 20. And then the root 6 has nothing to combine with, so it stays a root 6. Okay? Now the only difference between number 5 and number 6 is I can simplify this radical. What does the square root of 18 simplify down to be? 3 root 2, because of square root 9 times square root 2. The 9 becomes a 3, so how many root 2's do we have at the beginning? Lyle? How many root 2's do we get out of this? What does this simplify down to be? How about 30 root 2? Okay, and then minus 20 root 6. Okay? Now, did it do anything in terms of the subtracting? No, but you got to simplify and just see if possibly they combine together. So you got to at least try. Okay? All right, number 7. You try. All right? Casey, did you get number 7?
Yeah.
What'd you get?
50 and a radical of 6 minus 60 radical of 2.
And that is perfect. Anybody got questions on that one? From your negative 10 root 72, if you need it, you should have had 36 times 2. 36 is a 6, so that's why 10 and 6 make 60. Okay, so if you needed it. All right? Did anybody go ahead and do number 8? Andrew, did you get it? 15 root 2 minus, what'd you say? 18 root 3, which is absolutely correct. Anybody need help with that one? When you get your minus 9 root 12, don't forget you can take a 4 out of that. And the square root of 4 is 2, so 2 times 9 is 18. Okay? All right, flip over to the back. Okay? The last part, the solving. Okay? Now, the solving is going to involve what we talked about yesterday, and that is the dividing. So the big thing that we need to remember is how to rationalize a denominator. Okay? Otherwise, the solving is no different than if you were to solve any other type of equation. So, for example, if I had 2x plus 3 equals 7, you don't even have to write this down. Okay? You all know what to do, right? What would you do? Minus the 3. 2x is equal to 4. What would you do to get the x by itself? All right, so you all know what to do, okay? So if I wanted to get the x by itself on number 9, what would you do? Divide by the root 10. Anytime something is sitting next to it, it's multiplying, so we're going to divide by root 10. Okay, that gets the x all by itself. And are we allowed to have a radical in the denominator? No. So we are going to multiply top and bottom by root 10. That's that rationalizing part. Okay? When we do that, the numerator becomes 20 root 10. The denominator becomes the square root of 100. What's the square root of 100? 10. Okay? Can we simplify? Yeah? What would we simplify it to be? 2 square root 10, because 20 divided by 10, 10 goes into 10 once, 10 goes into 20 twice, it becomes 2 over 1. Okay? And that's it. If we were to check it, we would have 2 root 10, 2 root 10 times root 10 is equal to 20. Well, what's root 10 times root 10? Root 100, which is, so it's 2 times 10, 20. It sure is. It works. Okay? All right, so the big idea is you just have to possibly know how to rationalize. Okay? All right, so this one, I'm going to divide to get the x by itself. I'm going to do it all at once and just get it done. So I'm going to divide by 3 and root 7 to cancel the 3 and the root 7. So over here, I'm going to divide by the 3 and the root 7. Okay, and after that, I just have to simplify. This one we do not have to rationalize. Why?
Oh, cancellation.
Cancellation. So what do you get for your final answer?
I didn't get it.
What's 14 divided by 7? 2. And that should be in the numerator, because the bigger number is in the numerator. Okay, and then over 3. 7 goes into 7 once, and then root 7 goes into root 14, root 2 times. That's essentially what we did, was we divided by root 7. That's why we didn't have to rationalize. How are we doing so far? Anybody drowning out there? Yeah.
So if you cancel the root 7 on the left, so why didn't we put on the right? I know that you have to do it on the right side.
Well, we eventually did cancel it on the right. You said, why?
Like you said, if it's already canceled, is it because whatever we do on the left, we have to do on the right?
Yeah, so you remember, our basic equation? If I want to get the x by itself, I'm going to divide by 2, and I'm going to divide by 2. Whatever I do to the left, I have to do to the right. Okay? So over here, since I divided the left side by a 3 and a root 7, I have to divide the right side by a 3 and a root 7. I have to do it to both sides. Okay? And then from there, it just comes down to being able to simplify. All right, 11. Okay? For this one, couple of suggestions. Okay? It might make things a little easier. Number 1, when you have radicals that are not the same and you're adding and subtracting, try and get the same radical first. Okay? So I'm going to leave this as 5x root 3 because you can't simplify root 3. Can somebody simplify the square root of 27 for us? Okay, we've got a 3 root 3. If you need help with that, he did 9 times 3 is 27 and the square root of 9 is 3. Okay, and then equals 2 and what can we break down the square root of 243 to be? I think I heard an 81 times 3. What's square root of 81? 9. So what's 2 times 9? So let's actually make this 18 then, root 3. Okay? So the very first thing I did was I tried to get my radicals to be the same. And there's a reason for that, because now I am going to subtract my 3 root 3 to both sides. And now, since the radicals are the same, I can easily subtract them. What's 18 root 3 minus 3 root 3? This is what we did yesterday. Adding and subtracting, what do you do with the numbers in front? 15 root 3. 18 minus 3 is 15 root 3. Make sure you do not cross off the root 3, okay? If you have 18 bananas and you take away 3 bananas, you got 15 bananas, okay? All right, and then the other part, we still have our 5x root 3. So, to make sure you understand your question, what would you do here, Destiny?
You divide 5 root 3 to both sides.
Very good. Okay, the 5's cancel, the root 3's cancel, leaving x all by itself. On the other side, what can we do? Say it louder.
Divide 15 over 5.
15 divided by 5 is? Well, it's root 3 divided by root 3. 1, so it just cancels out. So our answer is just 3. Okay? All right, let's think about that. If I were to plug a 3 in up here, where the x is, I would get a 15 root 3 plus a 3 root 3 equals 18 root 3. It works. Okay? All right, try numbers 13 and 14 on your own. Okay? Number 13, you are possibly going to have to rationalize. We'll see. Depends on your simplifying methods. And then 14, my first suggestion would be to change the square root of 63 to something root 7. That'd be my suggestion. For number 13, x should equal a 1/2. Anybody got problems with number 13? Do you got number 14 done, or you need another little bit of time? All right. Yep.
I got x equals square root 7.
Not square root 7. How about? No. Oh, sorry. Yeah. Sorry. Yeah. You're right. Sorry. Okay. All right. You should have ended up this being a 3 root 7. So when you subtract the 2 root 7, you get x root 7 equal to 3 root 7. Divide by the root 7s. Oh, sorry. When you subtract the root 7, you get 1 root 7. Sorry. You get 1 root 7. So now when you divide by the root 7s, you're left with 1. Okay? All right. So you should get an x equal to 1. Okay? Questions? You got the idea? All right, so H-dubs then is, you've got